Hello. We are going to start off today with another bell ringer. What is the definition of thermal energy? Thermal energy, you should hopefully be able to say, is the sum of the potential and kinetic energies of a material. And today we're going to be talking about states of matter. So we've talked a lot about thermal energy, and now we're going to take thermal energy, that idea and all those concepts, and we're going to apply them to a new context, into talking about matter. So our learning objectives today are: I can describe the solid, liquid, and gas states of matter, and I can explain how the movement of the particles that make up a material determine the state of that material. So, first off, we need to know what matter is. What is matter? Anything that takes up space and has mass. So, oftentimes, when we're first thinking about matter, we might think about, especially solids, a table, a chair. You take up space and you have mass. If you step on a scale or on a balance, you have mass. Some things that we don't necessarily think about as being matter, but definitely are: the air that we breathe. It's all around us. And we do know that it does have mass, even though it doesn't feel like it has mass to us. It's because we're used to having it all around us and having that mass on our bodies. So, matter is everywhere, all around us. And matter is made up of particles. Usually, when we're talking about the smallest units that we can break matter down into, we're talking about atoms or ions. And we'll get more into specifically what atoms and ions are in probably about a week or two, maybe in the next unit. But those are the smallest pieces that we can chop matter into. And atoms and ions are what make up molecules. So molecules are groups or chains of atoms and ions. And the forces between these particles, between atoms and ions or molecules, is what determines the state of that matter. So it determines how we perceive it in the world. And I've got a little graphic there. We'll talk more about that in just a few minutes. The states of matter. So this is the different ways that matter can be in the world, how it can exist. And we're going to start off by talking about solids. So a solid is matter that has a definite shape and a definite volume. The particles, so those atoms, ions, or molecules, the particles in solids are very tightly packed, which means that the attractive forces between those particles are strong. So if you think about a magnet, when magnets are very, very close, especially if you have a very strong magnet, it's harder to pull them apart. And particles are just like that. When they're so close together, they're very attracted to one another. And all matter is made up of particles that move. So even though it might not feel or look like your table is made up of something that's moving, or you are made up of something that moves, all of the particles that make up your body, that make up your tissues, those are all moving at least a little bit. So particles in solids seem to almost vibrate in place. And when we talk about solids, we kind of talk about two basic types of structures: crystalline and amorphous. I think I might kind of be in the way of amorphous. But crystalline structures are very rigid and have like a very well planned organization. They're very organized. So as you can see in the picture on the left, on the bottom left, all of those particles, those represent different, probably in this case, ions. All those particles are arranged in a very organized way so that they can pack together and produce a structure that is really, really also very organized. So the example is salt. If you look very closely at a grain of salt, it's like a tiny little crystal because all of its particles are arranged in a very organized way. Amorphous material, however, is doesn't have a fixed shape. As you can see, the particles are all kind of put wherever they are. And an example of an amorphous solid is cotton candy. It doesn't have a fixed shape per se. It does have a fixed shape because all of those strands are a definite shape. But because it is a much less organized material, it has a much less structured shape. But it still has a definite shape, technically. So that's our solids. Very tightly packed, strong attractive forces, and definite shape and volume. Liquids, on the other hand, liquid is matter with a definite volume, but no definite shape. So the particles are more free to move past one another, and the attractive forces are weaker than in solids because they're moving a little bit more. Two big terms that we want to think about with liquids are viscosity and surface tension. Viscosity is a measurement of the liquid's resistance to flow. So that just kind of means like how thick it is. If you pour a liquid that's very viscous, it's going to take a lot longer to like flow out of its container. If you look at the picture or the GIF on the left, the liquid that's furthest to the left has a low viscosity, but the liquids that are on the right, furthest to the right, they have a super high viscosity because they're barely even starting to pour. So high viscosity means it's very resistant to flowing. It's not going to flow very easily. Think about like cold honey. It doesn't pour very well. But something with low viscosity pours really easily, like liquid water. Surface tension is the other term that we want to think about. And surface tension is the uneven forces acting on the particles on the surface of a liquid. So when we talk more about atoms and molecules, we're going to learn that some molecules are what's called polar. That means that even within the molecule itself, they have kind of like a positively charged end and a negatively charged end. And that causes them to interact with other molecules differently. And so surface tension, again, I think my head might be in the way, but if you can see right here, that is a penny that someone's dripped a lot of water onto. And usually we think of, because liquids don't have a definite shape, if you put a drop of water on something, we usually kind of think of it just kind of going wherever. But because of the edges of the penny and the attractive forces within water, when you put drops of water on top of a penny, they're actually going to kind of form like a dome. And you can actually get, I did this once and I think I got like 15 or 17 drops of water on top of a single penny before it splooshed everywhere. So surface tension creates almost like not like a force field, but almost like a force field type thing. It causes all of the liquid to stick closer together even when it doesn't have a definite container. And we'll talk more about that, like I said, when we talk about atoms and molecules. So we've talked about solids, talked about liquids. We better talk about gases. A gas is matter that has no definite shape and no definite volume. So like I said, the air all around us is matter, and I can hold it in my hands, but that doesn't mean that that's the shape of air. I can feel it moving past me, but it doesn't necessarily have a definite volume. The particles in gases are further apart and they move very freely, as you can see in the GIF. And the attractive forces between the particles are very weak because they're so much further apart from one another. A vapor, we'll talk more about this tomorrow, but a vapor is the gas state of a substance. It's normally a solid or a liquid at room temperature. So if you've ever seen steam is a kind of a good example, but we can vaporize, we can add thermal energy to something and cause it to exist in a different state than it normally would, because all of our states are dependent on the amount of energy that those particles have, right? So if we give something enough energy so that the particles behave in a way that they normally wouldn't at that particular temperature, then we can cause them to be a vapor. So again, I think unfortunately my head's in the way and I apologize about that. But if you look down here in the corner, here I've got a glass that has some liquid water in it. And then there's actually still molecules of water that exist as vapor. They're as a gas form above that liquid water. And so that's an example of a vapor. And that's all we're going to talk about for now, but I want to leave you with a question for tomorrow. So be thinking about this as you wrap up today's work and you start tomorrow. What happens when we change the thermal energy of a material? So if we increase or decrease the thermal energy, what happens to a solid? What happens to a liquid? And what happens to a gas? All right. Let me know if you have any questions, and I will see you tomorrow.